Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. As we go into this forecast, I want to show you the last 7 days of total accumulated precipitation and focus in on some of the very heavy rainfalls that have come out of the Red River Valley into parts of Arkansas, through the Mid-South, even getting over to the Tennessee and Ohio Valley. I'm talking about this corridor right in through here. Hurricane Laura came through first, and then following it, multiple almost stalled out frontal boundaries have been over the same area, producing large squall lines that have gone through there, and almost a very steady and heavy rain at times, where some locations have accumulated over 6 inches of rainfall. Scattered storms in the southeast, scattered storms over parts of the Four Corner states, and also here when you get up into the northern Rockies. Some heavier rain has moved through parts of Minnesota and Wisconsin in the last week and extended through Michigan and in over toward the northeast. But there's an area right in through here that over the month of August and now beginning September has had at best just a few chances of some precipitation, much of them being relatively light in amounts. Why I'm highlighting that area as we move on in this presentation is in the forecast for precipitation, there's the potential for some heavier rains into that area, but we have to talk about the differences in the model output to understand why there are going to be some major disparities here in the models coming up. So with that as the backdrop, I want to take you to satellite animation, but before I start it, I just want to leave it here just as the sun was setting last night. You can see the smoke and the wildfires in the western part of the United States, and that extends into parts of New Mexico, coming through parts of Colorado as well. Here are more of the big storms that we watched in the overnight hours that did roll through that place that was already very wet in the country here. And you can also, if I just take you back up to the northwest, you can see some of the storms there in the Cascade Mountains. As I play this forward, do keep an eye on the circulation that's out here in the open Atlantic as well, because we're going to talk first today about hurricanes. So here's the overnight hours. This is an infrared satellite image here. And as we see the sunrise this morning, you can see the circulation that is off to the right. That would be our next tropical system here moving out into the open ocean. And you can almost see the nature of that stalled out boundary in this particular vicinity, bringing in the heavy rains through early this morning down here, pushing into the Ohio River Valley in the near-term forecast. But I want to talk about tropics first, because right now we are watching really 4 different areas. We now have our next 2 named systems, Nana here, which will be moving right over the Yucatan Peninsula. There are lower probabilities now that this comes up into the Gulf of Mexico. And we have Omar, which is moving away from the coast. So neither of these 2 systems are an immediate threat to the United States, but the National Hurricane Center is watching the next wave coming off of Africa and right now giving it a 60% chance of developing. And there's a secondary wave to the south that also right now has a 10% chance of developing. We're going to keep a close eye on what's coming off of Africa. Now, what I want to do is I want to talk about what's going to happen as we move into the peak of the hurricane season. So September. I went back and I made a composite map from 1948 to 2019 of average sea level pressure. So this is the normal. There's a subtropical high that sits in here, and the flow around these high pressure cells, you know, is something like this. It's clockwise, okay? So systems that come off of Africa tend to follow the base of that and then are turned north around the subtropical high and also by the Coriolis effect. But do notice how we tend to get an extension of the subtropical high over here into parts of the mid-Atlantic. Now, why I'm starting off there was because I went back and I made a list of all of the seasons which we would define as hyperactive in terms of hurricane activity. I did this based on accumulated cyclone energy. Now the map you're looking at, which is over the same area, shows for those Septembers sea level pressure anomalies. And what I mean here is that the subtropical high just off the Iberian Peninsula during these years tended to be stronger. And this whole area in through here of lower atmospheric pressure was because that tended to be the favored track of tropical systems. That's why we see it there. Okay, with that as a backdrop, this was the latest update from the European model. So here's the Iberian Peninsula, and you notice that just off the coast right here is where the model is honing in on the high pressure center. And it is anomalously high in that area. My concern is that any system that develops here in what we call the main development region will then have great steering level winds that will push it toward the U.S. East Coast or Florida. We're going to watch for anything to develop in the Gulf of Mexico also as a result of this. What I don't see is I don't see anything here over the southeastern United States that would shut this down. And I certainly don't see this high pressure cell moving very far away from where it is here when you look over the next 30 days on the whole. So this is the steering currents behind our tropical systems as we now move into the most active time of year for tropical cyclones. Here's another couple of pieces to this. The Saharan Air Layer, it's the layer that has quite a bit of dust and drier air in it. We do see that over the next 10 days, it is sending quite a bit of dust out, and it's interacting with these systems. You can see it getting spun up right in here into the developing low that the National Hurricane Center is watching. There is still quite a bit of drier and dusty air in place, which the hurricanes are going to have to work against. And also remember, we have to talk about wind shear. Now the map over there on the left is for the tropical Atlantic, and the higher you go up on the y-axis, the greater the wind shear. Now remember, wind shear is a change of wind speed and or direction with height. Hurricanes cannot survive high wind shear environments. So the black line that runs through the middle of this graph shows us that during our hurricane season, which is here between June and November, that the wind shear is typically lowest. The blue line is 2020. We've recently popped back up with above average wind shear, and if we stay in this area, that could limit tropical cyclone development. But at this point, I don't see that necessarily being the case as we move forward. Likely hanging out around average is where we're probably going to go back to, which will be critical for the development of the next several systems. Here's the other piece to this, the Madden Julian Oscillation. Now the MJO came back out into phase 1 and 2 at the end of August and then moved here at the beginning of September through phase 2 and into phase 3. It is currently forecast to go somewhere here over onto the right side of the null phase, which is sitting in this area. What that more than likely means is we will develop a standing wave over the Indian Ocean. In other words, we'll have good upper level support here and over Africa for tropical cyclone development, but in the next 5 days, suppression, that kind of motion here across the places where you see the warmer colors. But as you go out now to day 10, if the wave does stand over India, as you see here, this will loosen up the Atlantic for better tropical cyclone development, and that seems to last all the way out to day 15. So we're going to watch these areas very carefully because the atmosphere is advertising better conditions for tropical cyclone development. So we'll keep an eye on what's coming off of Africa toward the United States. Another component of this would be La Nina. And over the next 15 days, you see the blues I've kind of highlighted here? Those cooler colors represent right into this area stronger trade winds. Now, stronger trade winds are a component of La Nina, and so are the ocean temperatures. And we can see the cooler ocean temperatures in here. Now, in several of my recent videos, we've been talking about how this La Nina would likely survive into September, October, and November, as would the warmer temperatures here in the Atlantic. By the way, before I talk much further, do notice right in through here, see it? That is the cooler water from Hurricane Laura and Marco that went through that area. Well, anyways, back to this La Nina. If the trade wind stays strong and the central tropical regions continue to lose momentum, that would be conducive to a low wind shear environment for tropical cyclones and a further development of this La Nina. Now, in this next animation, you will see that there is still plenty of cool water beneath the surface, that's the top line here, that can come up to the surface supporting this La Nina as we go into the month of September. And you see it right here. See the cooler water? This is mid-August, end of August, and now the beginning of September, it's there. So the Walker circulation in the atmosphere and the responding oceanic circulation says this La Nina has some life to it. Now there's another part of the tropics I want to discuss too, because currently in the West Pacific, we have 2 typhoons that we need to talk about. You see, these 2 typhoons are forecast to go one toward Japan, the other one toward the Korean Peninsula. Actually, both of them eventually end up over the Korean Peninsula. Now, while this is going to be a problem here in this part of the West Pacific, my concern is what happens after they go through the Korean Peninsula toward the northern China Plain and then eventually get absorbed into the jet stream. You see, if I give you a North Pole view of things by this Friday, let me find where those 2 pieces I was telling you about. Here's one of the circulations, and here's the other. Now, what I want to watch is to see if, over the next 7 to 10 days, if these 2 areas of lower atmospheric heights, which again are sitting up at the top of typhoons, do anything to reinforce this trough. You see, the trough that is currently sitting here that is south of the Aleutian Islands is the reason why we continue to see more ridging in the west and troughing over the Great Lakes. It's allowing the pattern to get bunched up a bit, giving us another big ridge just here in the North Atlantic. Now, those are the pieces we need to watch evolve in the coming forecast here, because they're going to have a major impact on this, okay? That particular area I just highlighted, from Kansas through Missouri, Iowa, Illinois, Wisconsin, up to the Great Lakes, this is an area that the models are not settled on just yet. Now, they are in great agreement about that. That rain there, this is coming through today. It's going to be heading into the Tennessee Valley, the Ohio River Valley. There will be scattered storms over the southeast, and we have to talk about the rain that are coming through this part of, out of Manitoba into Ontario and into Quebec, also clipping the Great Lakes. And then what about what's going on the backside here from Montana to Wyoming? You see, there's a lot of variability in the upcoming forecast, especially right in through here, because of the model differences that are showing up. And I think it's all because of the way that the trough is setting up over the Aleutian Islands. So keep that in the back of your mind. Let's see it here, okay? You see, this is the forecast from the 0Z run of the European, and I'm recording this too early in the day to give you the 12Z run. But if you notice, good agreement here in all of our models on the precipitation coming out of the Red River Valley over toward Arkansas, getting up into the Ohio River Valley. But just a little bit of rainfall here and here, with heavier rain coming out of parts of Manitoba over into Ontario and the Great Lakes. There's then more scattered storms that race up this side of the Rocky Mountains. Now, as I see that, I'm going to wait a minute. In the previous forecast from the National Weather Service over the next 7 days, this area in through here was very wet, yet the European doesn't have it there. Well, what about the GFS? Here's the 12Z GFS, which comes in faster than the European, and it is very wet in that area. It has the rain coming out of eastern Texas through Arkansas and eventually over into the Ohio River Valley. And it has some scattered storms on the backside, plus the precip coming out of Manitoba going into Quebec. It's also got those scattered storms in the southeast. But why is the GFS wetter here and the European is not? We got to answer that question. And to do that, I'm going to take you up to the 500 millibar level midway through the atmosphere and look at troughs and ridges. ECMWF, European, is on the right. GFS, that's the US models over here on the left. Now, can you see how they both are wanting to give you some sort of an omega pattern? See it? But see, the European is much sharper. And the reason why is because it takes this trough here and cuts off to its south a low that sits over the four corners. The GFS doesn't do that. It brings it as one united trough sweeping through much deeper, therefore colder, and out ahead of it much better upper level support for a lot of rainfall in this area. With the European lingering this cutoff wave back farther to the west, it tends to pile up the precip on the front range here and then sweep this through, eventually increasing rainfall chances later in the forecast, after the next 7 days are over. Let's see how this all evolves by day 10. You see, by day 10 in the GFS, the lead wave is now here, the ridge builds back into the west, but that trough is still there over the Aleutian Islands. What about the European? Nope, we still have the trough lingering here. We still have our Aleutian Island trough here, but the difference is the speed of the trough I'm going over right in that area. Notice how, if I just take that off there and make it clear, the GFS is farther along with it than the European. Now, why bring this up? We'll take a look at the week 2 precipitation patterns. With the GFS advancing the trough quicker, it brings the wetter weather into the eastern Corn Belt, parts of the mid-Atlantic, the Appalachian Mountains in the northeast, and dries things out west sooner. The European, letting the cutoff piece slowly move out, has in week 2 wetter conditions into this area, but also the wetter conditions that the GFS model has as well. It's all down to timing and if the wave does in fact cut off. If it does cut off, then the European solution is probably more correct. If we notice over the next few days that it is not doing that, then we'll stick with the GFS into week 2. In other words, we can make a plausible scenario for both models at this point. We got to watch it carefully and its trends over the coming days. Now, that same pattern has major implications on temperatures. As we play forward through the next week, here's Wednesday's highs getting into Thursday. Our first shot of cooler air comes into the northern plains on Thursday, as this low goes through the Great Lakes. The cooler air on Friday does extend from parts of the Ohio River Valley down into parts of central Texas, this whole area. But you'll see that by Saturday, the northern plains rebound. Now, if you're in the West Coast, just the entirety of my forecast for the next 15 plus days is hot for you. But the next chance at cooler weather, here's Saturday's highs. Watch this: Sunday, Monday, Tuesday. A big area of colder weather comes in with that trough that's diving into the middle part of the country next week. Now, seeing that, we start to get concerned at this time of year about frost. And I want to talk to you about frost. We're going to look at 6 different maps for 3 different time periods from 2 different models, okay? Over here in the top left, this is the GFS operational run for 6 a.m. Central Time on the 7th. Now, what I want you to be looking for here are these colors. That represents where the model is bringing below freezing temperatures. We've got a frost potential here in parts of Saskatchewan, Manitoba on the 7th. On the 8th, it now moves over into Manitoba, possibly clipping the northern part of North Dakota and northern Minnesota. And on the 9th, look at this. That's the full depth of the trough early in the morning on the 9th. We will not only have frost at the higher elevations here in the Rockies, but possibly extending in this part of Nebraska. See it? And then again in parts of eastern South Dakota, going up toward Minnesota and eventually in Ontario. Now, this is the GFS. In ensemble support, there's our possibility, our potential for frost. It's better than 50% in northern Saskatchewan and Manitoba. As we then go into Tuesday, you see it moving farther to the south. And by Wednesday, the ensemble support brings it over into parts of Manitoba and Ontario. But notice that the ensembles don't drop the frost into this part of the United States. It's just the operational runs across the top. Now remember, the GFS keeps the trough together and digs it right in the midsection of the country. It's our coldest solution that we have. What about the European? Doesn't have it. See? European keeps the cooler temperatures here and there. No indications of a frost event in this area because the European cuts off the low, detaches it from the true extent of the colder weather, and even in the ensembles, look, we don't see the high probability of frost coming down. So major differences in the solution here, we've got to watch it very carefully. But given that it's this time of year, we have to talk about what our average first frost dates are. Pause the video and take a look at this. You can compare the dates over here on the left to your location. What I want to show you, though, to supplement this work by Brian Brett Schneider here, which you can see his name down at the bottom, I want to show you some work that I put together this morning. So I'm talking about here is what decreases the likelihood of a frost first. So think about that. Windy conditions, clouds, warm soil. Plus, remember, the plant canopy can hold in the heat as well. So the map in the background says, how many times since 1981 have we had a frost by September 15th? And if you just look here closely, first of all, put this in full screen on your computer. What you'll see is that when you get down to here, there's only been 1 or 2 times where we've had a frost extending this far to the south by September 15. But as you get back here into this part of the country, generally 7 to up to 20 times since 1981, we've had a frost event. All right, so keep that in mind. A September 15 frost in the U.S., especially here, is more on the rare side of things. From there, I want to show you how far we've made it in terms of accumulating heat units. So beginning on April 1st through the beginning of September here, what percentage of the way have we made it to getting 2,500 GDUs? Well, everywhere that's white, we're past that. But everywhere that's green, well, we can see that parts of North Dakota, for example, are 75 to 85% of the way to getting 2,500 GDUs. Same thing for northern Minnesota, Wisconsin, and Michigan. And it's a little bit more as you get back into parts of the plains of Montana. So I just wanted to add that for some perspective here. Now, looking at temperatures, we see that in the 6 to 10 day, with the big ridge going west, both the GFS and the European are warm. And here's that cooler bit of air that's coming down. Notice the GFS keeps a nice big bowling ball of it here, where the European splits it. See it coming back to the west here? That's the difference between that cutoff trough. By the time we get to the 11 to 15 day time period, they still show similar ideas, but notice that the cooler weather extends farther to the east in the GFS, bringing the trough through faster, whereas the European lets it linger a little longer here into the middle of the month. Now, thinking about that, let's go out into week 3 and week 4. When you stretch this out, we notice that September 16th to the 22nd, the European says, you know what, we might still have some cooler air in here, still some heat on both coasts. But by week 4, which is September 23rd to the 29th, it brings back over near average to warmer than average conditions. It's been doing that for the last 3 runs. It is also calling for September 16th to the 22nd, active tropical cyclone activity here. Do you see it? And then interestingly enough, by the 23rd to the 29th that week, it is bringing in more scattered storms back into the central and northern plains. From there, let's do a little bit of model comparison. CFS V2, week 3, week 4. Notice, same thing here. See that the storms here, week 4, and drier in week 3 with the more active tropical cyclones coming out of the Gulf going here to the East Coast. Similarities there. We're also similar in the fact that we're keeping some cooler air through mid-September, but then warming things up at the end of the month. So the last thing I want to talk about would be what could make the end of September warm, thus prolonging any area that maybe doesn't get a frost on that 7th, 8th, 9th time period, keeping it away longer. Well, this is what you want to do. Jetstream, okay? What I've got here for you are Septembers that were warm. The jet stream tended to be fast and extend itself all the way here through the Gulf of Alaska. So what we have over here is a large ridge over the Great Lakes and another one right here. Can you see it? Just off the Aleutian Islands. That's why I've been so concerned about that Aleutian Island low. If it goes away, we will go back over toward warmer, all right? So what about the cooler side of things? Well, now if you take a look at this, you see the jet stream winds back up here and slow down. There's a trough over the Aleutian Islands, split flow over the west, and another trough over the Great Lakes. You can see it in the anomaly plot on the right or in the flow over here on the left. If I go back and forth, just look at the difference. I want you to look over here on this figure. Look at the difference here. Whoops, sorry. There we go. See the difference here? Cooler for the Great Lakes and Central Plains, warmer. That's the difference. If this pattern evolves, the west is going to stay hot with split flow. We'll be cool in the midsection of the country. From there, what are the models saying? Well, through the next 15 days, there is split flow. See it? And there's a low over the Aleutian Islands. That's the dip right here on the lines. Therefore, we're going to stay cool through the next 15 days in the central part of the United States. But beyond that, watch right here first, and then see how the jet stream either flattens out or splits over the west coast. That will tell us how the end of September will unfold. I'll keep you updated, okay? Thanks for your attention. Look forward to talking again tomorrow morning. Have a good one. Thank you.